reading the periodic table. So first of all, what's the periodic table? The periodic table is a tubular array of chemical elements organized by atomic number, from the element with the lowest atomic number, which is hydrogen, to the element with the highest atomic number, which is oxygen. Elements are the building blocks for everything in the world. Depending on the temperature, they can be solid, liquid, or gas. Most occur naturally, such as oxygen, gold, copper, carbon, and helium. The periodic table is a way of arranging all of these chemical elements and putting similar ones together. Each square on the table includes a number and letter. The number, which is the atomic number, the protons number, and the atomic number, which is the number of protons and electrons, and the letters. The letters are the chemical name of the elements. For example, oxygen is O, but gold actually is AU. So every element has its own letter to identify. Atoms are the smallest particle of the chemical elements that can exist. There are actually 118 known elements, but only 94 of these are thought to naturally exist on Earth, while others have been done by in labs of science. So next, we're gonna talk about the history of periodic table. By 1860, more than 60 elements had been discovered. So chemists had to learn the properties of these elements. There was no method for accurately determining an element's atomic mass or number of atoms of an element. So in September 1860, a group of chemists assembled at the First International Congress of Chemists in Germany to settle the issue of atomic mass. So an Italian chemist called Stansillo presented a convincing method for accurately measuring the relative masses of atoms. So his math had forced actually chemists to agree on standard values for the atomic mass. So another chemist appeared, which is Mendelvey, which was called the father of periodic table, because he invented the periodic table after this congress. Heard about this congress in Germany, so he decided to new values in chemistry. So he decided to organize the elements according to their properties, which is the atomic mass. So Mendelvey placed the name of each known element on a call together with the atomic mass of the elements and listed to observe physical and chemical properties, then arranged the codes according to various properties and looked for trends or patterns, similarities actually. Mendelvey noticed that when the elements were arranged in order of increasing atomic mass, certain similarities in the chemical properties appeared at regular intervals, such as repeating pattern is referred to as periodic. Next, how is periodic table arranged? So how was the periodic table arranged in the periodic table? How did Mendelvey actually arrange it? The periodic table elements arranged from left to right and from top to bottom in order of increasing the atomic number. So the horizontal row are called periodic, while the vertical columns are called groups. So the horizontal rows, which is periods, which is the number of an element, signifies the highest energy level an electron in the element occupies. And there are actually two elements in period 1, which is hydrogen and helium. The number of electrons in a period increases as one moves down the periodic table. Therefore, as the energy level of the atom increase, the number of energy sublevels per energy increase. So, as we said, the vertical columns are called groups. So, groups have identical valence electron configuration and consequently behave in a similar fashion chemically. So they are organized in patterns. Each element has its own chemical symbol made from letters. As we said, oxygen has the symbol O. Only elements are found in the periodic table, never compounds. For example, the substance like water, which is H2O, you will never see the symbol H2O in the periodic table because it's a compound, and also copper and sulfate. Then, how to read a chemical element. So the periodic table are made of small squares So let's see if you want to read the oxygen, for example. So the atomic number, which is the number of protons in an atom, is located at the top, while the symbol, as we said, of the oxygen is O, is located under the atomic number, and then the name of the atomic number, which is oxygen, and the atomic mass, which is the total number of the negative charge, which is electron, and the positive charge, which is proton. Now, I'm gonna talk about the 8 main groups in the periodic table. So, first of all, the alkali metal group, which is group 1. The alkali metals are 6 chemical elements: lithium, sodium, potassium, rubidium, cesium, francium. Alkali metals have only one electron in the outer shell. One electron. Alkali metals are very reactive. They appear silvery and can be cut with a plastic knife. They must be stored under oil to keep air and water away from them, because as we said, alkali metals are very active, so to prevent them from reacting with air and water, we should keep them stored under oil. Okay? Then the second group, which is group 2, alkaline earth metals, it consists of 6 chemical elements, which is beryllium, magnesium, calcium, strontium, barium, and radium. All of the alkaline earth metals react with the halogens to form the alkaline earth metal halides. So they are probably reactive. So they react with the halogens to form alkaline earth metal halides. They are shiny silvery white and somewhat reactive metals at standard temperature and pressure. Alkaline earth metals have 2 electrons on its outer shell. So as we said, alkali has only 1 electron, while the alkaline earth metal has 2 electrons. The alkaline earth metals has low densities, low melting points, low boiling points. All the alkaline earth metals, except for the beryllium, also react with water to form strongly alkaline hydroxide. So all of them, except for the beryllium, react with water. Next we have group 13 and group 14, which are known to be the most main groups in the periodic table. So let's start with the boron group. It consists of 6 elements: boron, aluminium, gallium, indium, thallium, neodymium. Each element in the boron group has 3 electrons in its outer shell. So boron is classified as metalloid, while the rest, with the possible exception of unternium, are considered poor metals. The unternium are not yet confirmed to be a poor metal due to a relativistic effect, might not turn out to be one, so just skip out the unternium. Is generally unreactive with many, so the boron group is generally unreactive with many elements except at high temperature. So the substance should be at high temperature in order for the boron group to react with it. Also, although it is capable of forming many compounds with hydrogen, sometimes called borons. So they are unreactive with elements with many elements except if they're at high temperature, and they can create they can form many compounds with hydrogen. So let's go to group 14, which is carbon. It consists of carbon, silicon, germanium, tin, lead, palladium. Okay, so each element in carbon group have 4 electrons in its outer shell. So carbon is of course non-metallic, silicon, germanium are metalloids, and tin, lead, palladium are metallic. Okay, the change from non-metallic to metallic will increase the atomic number. The group 14 elements tend to adopt oxidation. +4, which is the number of the electrons, as we said. For heavier elements, +2, so it's only need 2 electrons due to the inert pair effects. Okay, the next, which is nitrogen and oxygen groups. Group 15, nitrogen, consists of nitrogen, phosphorus, arsenic, antimony, bismuth, and conscovium. Nitrogen group have 5 electrons on its outer shell. Nitrogen and phosphorus are nonmetal. Arsenic and antimony are metalloids, so bismuth are metal. Except for nitrogen, all elements are solid at room temperature. They more often form covalent compounds unless bonded to an active metal. So they also form compounds. The oxygen, which is group 16 and also known as chalcogens, the group consists of oxygen, sulfur, selenium, tellurium, polonium, livermorium. Chalcogens group have 6 electrons on its outer shell. Oxygen is gas, sulfur is nonmetallic, selenium is metallic, tellurium and polonium is metalloids. Livermorium is unknown, but probably metallic, but it's still unknown. All chalcogens are very reactive to alkali earth metal, which, if we can remember, which is group 2. Next, the halogene group and the noble gases group, which are the two last main groups in the periodic table. So let's start with the halogene group, which is group 17. It consists of fluorine, chlorine, bromine, iodine, acetine, and tennessine. Halogene group has 7 electrons on its outer shell. They all produce sodium salts of similar properties, of which sodium chloride table salt or halite is best known. Halite is best known because it's been known halite for many years, and they called salt halite the past ages ago. Because of their great reactivity, the free halogene elements are not found in nature because they're really reactive. Halogene group elements are toxic, so you can't find them in nature, and they are non-metallic. Because the halogene elements have 7 valence electrons, as we know, they only require one additional electron to form a full octet, which means because to form a full electron, it should be 8. That's the maximum number an octet can have. So it only need an additional electron to form a full one. This characteristics makes them more reactive than other nonmetal groups. Halogene form diametic molecules. And then we have group 18, which is the last main group, noble gases. The group consists of, it's called noble gases, so it's probably made of gas. So the group includes helium, neon, argon, krypton, xenon, radium, and thinnic element oxygen, which is all gases. The noble gases are a group of non-metals, of course. They are often described as chemically inert. That means they are colorless, odorless, and highly unreactive. Sorry. So let's see. Yeah, the noble gases, we said they are colorless, odorless, and highly unreactive. So that's why we can find them in nature, such as oxygen, carbon. They are all found in the air. They have 8 electrons on its outer shell, so that means it's full. Means that an atom is already in its most stable state. There is no need for atoms to lose or gain electrons because it already has the 8 electrons, it's full. Xenium has a unique electron configuration which allow it to accept more than 8, and now that's the point. The gas xenium has a unique electron configuration which allow it to accept more than 8 electrons on its outermost shell. The noble gases were discovered in 1895 when Sir William Ramsay and Lord Rayleigh isolated an unreactive chemical substance that was heavier than nitrogen from the air. So now that when the noble gases popped out, actually. Next, we have the periodic table of elements. So the alkali metal, which is lithium, sodium, potassium, rubidium, cesium, francium, are located here with the color red, and the alkaline earth, which is in the color orange actually, beside the alkali, beryllium, magnesium, calcium, strontium, barium, radium. It's located here, and the transition metal these are the metals that can transit itself to non-metallic or metallic, but these are not one of the main ones, so I didn't mention it in the PowerPoint. We have the noble gases here, which are, as we said, oxygen, radium, oxygen, and helium, neon, argon, and the others. So this is the periodic table. The hydrogen is located here, and the helium is located here. The boron is here, which is which we mentioned actually, and the carbon, nitrogen, oxygen are here. Okay, so that actually was my video. Thanks for watching and listening.